So if we have a theodolus that's set up right here, and this is our 0 degree line here, in other words, our reference line, and we have we'll call this point A, B, C, and D, like that. I didn't label them exactly like they were in the thing. On your worksheet, it tells you that each grid is 4 feet. So for A, it's actually 8 feet over and 8 feet up. So they're using as a grid like this, similar. I'm doing mine purposely different, like that. So if each grid, if each box is 4 feet on a side, that means A is at 6 feet this way and 4 feet this way, right? Rather than counting boxes for the rest of them, I'm going to tell you that I am building a garage. Oh, sorry to yawn in your ear. It feels like that kind of day, though, doesn't it? Let's say that it is 32 by 48 feet. Obviously not drawn to scale here. So anyway, our distance to this corner here is 6 and 4. So let's say I give you, I'm going to do an example here of this. What I need to find is this angle and this distance. So the distance is going to be found as the square root of the vertical squared plus the horizontal squared. So square root of 4 squared plus 6 squared. 7.211 feet. Oops, that's not right, is it? This isn't 4 and 6. You guys said yes when I put that down there. This is how much? 8. And this is how much? 12. There we go. So 8 squared plus 12 squared looks way better. So let me try to do the right answer. Second square root. 8 squared plus 12 squared. Let me try that again. There it worked. 14.422. So 14.422 feet. The angle is the inverse tangent of the vertical, 8 over the horizontal of 12. So second tangent, 8 divided by 12. 33.69 degrees. Does that make sense? So let's walk through point B then. On your quiz, you'd have to count the boxes. Here, we know the vertical is still how much? 8. The horizontal is 12 plus 48, so the horizontal is now 60. So this was point A here. For point B, how are we going to find the distance? Square root of 8 squared plus 60 squared. Very good. Get back here. $60.531.
Oh, I did 12, sorry.
Okay. It's got to be 8. There you go. And then the angle is going to be what? Perfect. Inverse tangent of 8 over 60. .59 degrees. Make sense? So I want you to find for C and D, find the distance and the angle for C and D quick in your notes. So for C, our distance will be the square root of 40 squared plus 60 squared, correct? Giving us 72.111. Angle, inverse tangent of 40 over 60. .69 degrees. Perfect. Both of you good with both of those? Beautiful. For D, our distance will be the square root of 40 squared plus 12 squared. It was 41.761. And the angle, inverse tangent of 40 over 12. .70. We've got her down. Do you need time to work on that quiz, to rework that problem at all? Well, I guess Tate and Richard won't be back till Thursday, so. But I'll give you a minute if you want to rework those problems right now. I'll give you like 5-10 minutes.
Yes.
Let's do that. I'll leave this up for you. Okay, so now I want to go kind of in a little bit of review mode. There's some things that we've kind of touched on, but I'm not totally sure just how detailed we've got into them. So I want to make sure we've got them down solid. So I want to first talk about coterminal. Coterminal, if you remember, we talked about this unit circle and how all of our angles on the unit circle start out here at 0 degrees, right? And that is referred to as the initial side. And then the angles move counterclockwise around that circle. So like here, this is a 60-degree angle. That side is called the terminal side. But that would be the terminal side for a 60-degree angle because that's where the 60-degree angle would stop if we rotated 60 degrees around the circle. The problem is it's not just a 60-degree angle. There are other angles that would have that same terminal side. Because it's a circle, I could wrap around once and back to there. How many degrees would that be? Yeah, 360 plus 60. Or I could wrap around twice and back to there. That would be 360 times 2, or 720 plus 60, which would be 780. Or I could wrap around 3 times, or 4 times, or 5 times. You guys get the picture. Or I could go backwards. That would be 60 minus 360, or a negative 300 degrees. These are all what we call coterminal angles. They're called coterminal because their terminal side is at the same spot right there. So if I give you, when we're looking at these angles, they all have the same sine, cosine, tangent, secant, cosecant, cotangent, etc. So when I'm looking at them, if I'm doing the sine of 420 degrees, I don't really need to do the sine of 420 degrees. I could just do the sine of 60 degrees. Now, nowadays with modern calculators, I can type in sine of 420, and it's going to give me 0.866. Sine of 60 would be 0.866. So our modern calculators can do this. Or I could type in the sine of negative 300. Guess what? 0.866. The modern calculators can handle this. Before my time, well, before my time teaching at least, back in early 80s, most of your calculators could only do up to 90 degrees. So that's why we didn't, we had to deal with it. Also, before that, way before my time, before calculators did trig functions, you had to look them up in a table. Have I ever showed you one of those tables?
No.
Let's see if I can pull one up here. Tail? How about table? There we go. So here's a trig function table. Let's see if we can make it big enough to see. Of course, they're not going to let us do it the easy way. You actually had, before the calculators did this, you'd actually have to look up and say, okay, my angle is 60 degrees here. Oops, whereas it's over here. This one only goes up to 45, actually. Why does it only go up to 45? Well, I'm trying to find the sine of the angle of 60 degrees, right? Well, I know the sine of 60 is going to be the same as the cosine of 30, so I don't have to go up to 45 degrees. So I go to 30, and I go to cosine, 0.866, right there. So in order to make these tables more compact, they did that. So then, if I wanted to sine 420, I'm not going to let this table, obviously doesn't go up to 420. There are a bunch that go up to 90 instead of just 45 like this. In fact, let's go ahead and find one that's a little bit more in-depth, intense. These are good. They all go to 45. This one? That's 45. That's 45. Oh, that one does go to 90. You are correct. Here it is. This one's a little hard to see, but it does go up to 90. So 60 degrees is right there, and there it is, your 0.866. A little hard to read because it's small. There are some that would actually go, 1, and then 15, 30, 45, 15 minutes, 30 minutes, 45 minutes. And I actually have a book of trig tables up in my office. It's like 40 pages of trig tables, so it breaks it down, I think, to every 10. No, actually, it goes to 5 minutes instead of, because typical they start at 15, and then they want to keep those 15 because 15 is a quarter of a degree. So they go usually 15, or if they go more precise than that, then it's 5. So you keep the 15, 30, and 45 are the ones you want to keep in there. So generally with these, if it's like 15.3 degrees, they did extrapolating. You looked at 15 and 16 degrees, you saw the two numbers, it's closer to 15 than it is to 16, so you kind of estimate it closer to the 15 than the 16. So it's an estimate pretty much. But you can see they're not going to go up. This one went up to 90, most of them went up to 45. They're not going up to 420. So you had to know that coterminal. You had to know I'm going to subtract 360 to get to 60 degrees. Like I said, modern calculators, not nearly as important as it used to be. I wonder if there's any other. These I think are done. Oh, that one's just the standard ones. The 0, 30, 45, 60, and 90. Okay. Enough of that. So you get the picture. The modern calculator, the idea of terminal angles is not such a big deal. In construction, you're not going to work with too many angles over 180 degrees. I mean, definitely not going to work with angles over 360 because it's a full turn. Where this really comes into play is if you're getting into electronics, communications. You got a sine wave that transmits your signals and whatever. Well, at what point does the signal have to repeat itself? It has to repeat itself every 360 degrees. So at 60, 420, 780, 1,000 and 1,140 or whatever, that signal will be at the same point. It'll repeat itself. Okay. That's actually how they stack signals. One sine wave, one signal can actually carry multiple signals because this section of the wave carries this signal, this section of the wave carries this signal. So if it's let's say it's a 60 to 70 degree signal, it reads 60 to 70 degrees, and it reads 420 to 430, and so that's just the piece that reader reads to get that part of the signal. So if I give you, I want you to, usually they say find the coterminal angle. They often leave this out, but technically they should say find the simplest. Because simplest technically means between 0 and 360 degrees. But when they say find coterminal angle, they mean find the simplest coterminal angle. So if I say 570 degrees, what are we going to do to it? I'm going to subtract 360. That's 210 degrees. There's my coterminal angle. If I give you 910 degrees, what am I going to do? Well, we're going to subtract 360 first. Get 550, then we're going to subtract it again. 190 degrees. What if I have a negative 412 degrees? Add 360. Very good. We add 360, we're still at negative 52. Then what? Add 360 one more time. We're at 308 degrees. So that is how you find coterminal angles. Next, I'll talk about reference angles. We've talked about these before. Remember, we have our circle. We referred to this horizontal diameter as the reference diameter. That reference diameter, now usually we have a vertical diameter drawn into, but that horizontal diameter is the reference diameter that we use for reference angles. So if I have, let's say this is a 53 degree angle. The reference angle is the angle to the reference diameter. What's the angle back to the reference diameter here? 53 degrees, yes. If our angle is in the first quadrant, the reference angle is just equal to the angle. Make sense? 53 degrees has a reference angle of 53 degrees. If I have an angle of 19 degrees, it has a reference angle of 19 degrees. Let's say I have an angle here of 127 degrees. The reference angle is the angle to the reference diameter. That would be this angle here. Yes, remember, this is the 127 here. That reference angle would be 180 minus 127, or 53 degrees. Does that make sense? So in the second quadrant here, which is from 90 to 180 degrees, the reference angle is 180 degrees minus the angle. So if I have 102 degrees, the reference angle will be 78 degrees. Perfect. If we have 219 degree angle, that 219 degrees is right here. My reference angle is going to be here, back to the horizontal, closest horizontal. What's that angle going to be? 39. In other words, it's going to be the 219 minus 180. So in this quadrant, from 180 degrees to 270 degrees, it's going to be the angle minus 180 degrees. Now don't confuse it. Up here, it was 180 degrees minus the angle. Here, it's the angle minus 180 degrees. Again, we're just looking at the closest way to get back to that reference diameter. So if I have a 258 degree angle, what's my reference angle? 78 degrees. Very good. 258 minus 180. So if I have a 289 degree angle here, again, 289 degrees is right there. This one, the closest way back to the horizontal is right there. How am I going to find that? 360 minus 289 is going to be 71 degrees. So in that quadrant, the fourth quadrant, which is our 270 degrees to 360, it is going to be 360 degrees minus the angle. So if I ask you to find the reference angle for problem number 1, 248 degrees. Tell me what to do. Let's do that. You say 360 minus 248. Do 360 minus 248. That's going to give us 112 degrees. A reference angle has to be less than or equal to 90 degrees. So that can't be the right one. But it doesn't hurt to try it. We know that we get 112. That can't be right, though. $248 minus 180. 68 degrees. Remember, if you're thinking unit circle, this is 0, 90, 180, 270, 360. 248 is in here. So we've got to go back to 180. Yep. So, angle 2, find the reference angle for 301 degrees. What's that? You got it. How'd you find that? 360 minus 301 is 59 degrees. That is correct. How about for 21 degrees? What's my reference angle? 21 degrees. Good. How about for 142 degrees? What's my reference angle? 180 minus 142 is 38 degrees. Wonderful. It is break time. Let's take a quick break. We'll come back here about 10:32. And we'll keep going with some of this review, and then we'll take a quiz. It's going to be calculator workout time. If I ask you for the sine of 143 degrees, what's it going to be? What's that? 0.601. Okay. So we can find the sine of 160 degrees. But I want to know the sine of what other angle? 0.601. Now, obviously, I could add 360 and get 503 degrees. That would work, right? Because it's a coterminal angle. But there is another angle between 0 and 180. It also is 0.601. Remember, unit circle. (143 degrees is somewhere in here, right? This is the 0.601 right here. What other point on this circle is that same height above that reference diameter? One right over here, right? How do I find that angle?
180 minus 143.
Perfect. 180 minus 143 is going to be 37 degrees. Check that out. Does sine of 37 degrees also equal 0.601? Yes, it does. The cosine of some angle is going to be 0.601. The cosine of what angle? Or what does co mean? CO means complement. So the complement of 37, right? 90 minus 37 is going to be 53 degrees. Check that one out quick. Cosine of 53. Make sure it's 0.601. And it does. Good. How about the cosine of 124 degrees? Now, before you punch this in, positive or negative? Cosine is positive over here, negative over here. 124 degrees is over here. So it's going to be negative. Okay, punch it in.
Negative
0.559. Negative. What's that?
456.
0.560. Yeah, 0.559. Negative 0.559. We want to go at least 3 digits. I usually go 3 or 4 digits with my trig functions. So, of course, there are sine functions that correspond to that, but it's going to be a little uglier because we're past 90 degrees. Let's try the cosine of 18 degrees. What's that one going to be? 0.951? Okay. Is there another angle that has that same cosine? Remember, there's my 18 degrees. I follow that down. The cosine is this distance right here, right? Is there another angle that have that same distance? If my circle was actually more circular, it'd look better, but if that's 18 degrees, what would that angle be? Yeah, 360 minus 18 is 342 degrees. Cosine of 342 is also 0.951. And it does work out. Tangent. 37 degrees. Now, before you punch this in, is this going to be bigger or smaller than 1? Smaller than 1. How do I know that? Not sure. Oops, get back here. 45 degrees is right here, right? In 45 degrees, this side and this side will be the same size, right? So tangent of 45 is 1. If the angle is smaller than 45, it's going to be less than 1. Bigger than 45, more than 1. So this comes out to be 0. What? 0.753. Works for me. We're going to find a cotangent of 53 degrees. How did I know it was going to be 0.753? Well, those are complements, right? Cotangent means tangent of the complement. But if we didn't have this one already, how did we find it? We did tangent of 53. We close the parentheses, then hit that reciprocal key. 0.75, technically 0.754, right? 754 if we round it. How about if I ask you to find the secant of 18? Now, don't punch this in yet. Less or smaller than or greater than 1. Secant is always greater than or equal to 1. Sine and cosine are always less than 1.
Okay.
But they're between -1 and +1, technically. So the secant always has to be bigger than 1 or smaller than -1, one of the two. How are we going to calculate this? Secant goes with cosine. So we're going to type in cosine, 18, close parentheses, and then reciprocal. Cosine, 18, close parentheses, reciprocal. 1.051. Can you get that to work out?
Yep.
So how about cosecant? 72 degrees. $1.051. Well, cosecant goes with sine. Here's sine 72, close, and then reciprocal. 1.051. So I want you to find for me the sine, 81 degrees. Cotangent, 13 degrees. Secant, 27 degrees. Cosine, 51 degrees. Tangent, 14 degrees. And finally, cosecant, 52 degrees. Find those in your calculator for me quick. You got her? We need a minute. Just a minute, okay. Ready? Sine 81, what'd you get? What's that? 988. Do you concur? Cotangent of 13. .331. Let's double check it. So it's going to be tangent of 13, closed reciprocal. It should be a big number, so that sounds right. 4.331. You are correct. Secant of 27. That cannot be correct. Secant has to be bigger than 1. 1.123. Let's check it out. So secant goes with cosine. So cosine of 27, close parentheses, and then reciprocal. 1.122. Cosine 51. 629 work. Tangent of 14. 249. Cosecant of 52. Can't be 0.6. Has to be bigger than 1, remember. 269, 1.269. Let's check it out. So we're going to cosecant goes with sine. So sine of 52, close parentheses, and then reciprocal. 1.269. What do you guys think?
The terminology.
Yeah.
But it's not bad.
Okay. We can do inverses, but inverses are not on this quiz. So I'm going to give you the quiz first, and then we'll do inverses in the last 10 or 15 minutes here. So I'm
I'm done.
Are you all done? Oh, okay. So the next side of this is, of course, if sine of A equals 0.281, how do I find A? Yeah, inverse sine of 0.281, right? Second sine 0.281. 16.32 degrees. If I tell you that cosine of B is 0.942, B is found by doing the inverse cosine, so second cosine, 942, right? Gives us 19.61. And if I tell you that tangent of angle D equals 2.873, D is the inverse tangent of 2.873. Second tangent, 2.873, otherwise known as 70.81 degrees. But let's throw the wrench in the system. Let's say the secant of angle F is 1.875. How do I find angle F? F is going to be found, of course, secant goes with cosine, so I'm going to do an inverse cosine, 1.875. Now here's the difference. I put my reciprocal inside before I close the parentheses. So I do second cosine, oops, clear that out. Second cosine, 1.875. Hit my reciprocal, and then I close the parentheses. 57.77 degrees. Look familiar? Cosecant of angle G is 2.111. So that means G is going to be what trig function goes with cosecant? Sine inverse of 2.111. Reciprocal inside the parentheses again. .28 degrees. And of course, if I tell you that the cotangent of angle H equals 0.991. That means H is the inverse tangent. 0.991, and of course we do the reciprocal inside the parentheses. So So second 10.991. Reciprocal, then close. 45.26 degrees. So the key is trying to remember, when does that reciprocal key go? Inside the parentheses? And when does it go outside the parentheses? Because here this would be the cosine of 27 degrees with the reciprocal outside the parentheses. If we know the angle, that reciprocal goes outside the parentheses. If we're trying to find the angle, reciprocal goes inside the parentheses. So in your book, page 7, I believe it's page 775. Exercise 36-3, 1 through 11, the odd. And on page 778, exercise 36-5, 1 through 10, 1 through 9, the odd. You work on those, that'll review some of the stuff we went over today. Let's see. I see you guys again on Thursday, right?
Yes.
Thursday, I maybe have to start a little bit late. It's right after lunch, yes. I am in an interview committee on Thursday. Well, it's not an interview. It'll be a screening committee, actually, 4 interviews. It's supposed to start at 11:30. I think we get done at 1. So if you come in here and I'm not here at 12:30, if I'm not here by like 12:35, take off and come back at 1.